Hello and welcome to my video, lesson 7.3, logarithm laws. So just before we start, I just want to remind you guys or let you guys know that the following rules only apply if the two logs have the same base. Okay, they need to have the same base. We're going to use log 10 most of the time, but in these questions I chose to do logs whatever in order to get you guys practicing. All right. And these other ones will show up for sure as well. So, product law. Okay, product law is, the formula is shown right here. So what that means is that if we have two of the same base log, we can add or multiply the insides if we're adding the logs. So we're going to multiply the insides if we're adding the logs. So for example, this can go to log still base 2, just as before, but 4 times 8, which is 32. Okay, and now we can solve the answer or the question. So it's just a reminder about how to do that. We have 2 to the exponent x equals 32. So our question is, what is x? So we go 32 divided by 2 equals 16, divided by 2 equals 8, divided by 2 equals 4, divided by 2 equals 2. And then we just count up the number of 2's that we used, 1, 2, 3, 4, 5. So 2 to the 5 equals 32. So x equals 5, and our answer is 5. All right, looking at the next one, we have quotient law. So product law is if we're adding. Guess what? Quotient law is subtracting. So product law, adding, gives you multiplication. Quotient law, subtracting equals division. This is actually a very similar sort of idea as if we had, and there's no surprise because they're related, if we had exponential functions, right, and we're multiplying them, then what do? We add the exponents, 5 plus 2. Why are we adding? Well, we're adding, and it's the opposite of what we're doing here. So in logs, if we're adding the logs, we multiply the answers. If we do that for exponential functions, we're multiplying the answers, and we add the exponents. So see how those are opposites. And then the same thing for quotient law. If you have 10 to the 5 and you divide by 10 to the 2, well, it's as if you had 10 to the 5 minus 2. I apologize about that. I'm at school and they ring sometimes. So 10 to, minus 2. Okay, so same thing here. We're going to be subtracting now instead. Subtracting means that we're going to be dividing. So let's change this. Log base 3. And so we're going to be dividing. So this is going to give me 27. 54 divided by 2 is 27. Okay, then what we're going to do, again, same as before, 3 to the x equals 27. Then we're going to take 27 divided by 3 equals 9, divided by 3 equals 3. And so here now we can see that there are 1, 2, 3 3's needed. So x equals 3, so our answer equals 3. Okay, and our last law is the power law, and then you guys can go ahead and try this example question below. So power law, right here. What are we going to do? Well, it's kind of like how if we had 10 to the 5 to the 2, then we multiplied the exponents. This is related in concept here. Okay, so it's kind of weird, but it might show that it's related a little bit. Might not. Okay. So, anyways, let's ignore this because it's harder to understand than the other two. But let's take a look at power law. If we just follow the rule, well, we can take the exponent and put it out in front. So notice how it's now in front. So if we do that for our example here, then we have 3 log base 3 equals 27. Okay, so now we're going to figure out what that is. So just the part inside, not including the 3. So 3 to the x equals 27. And I mean, we just did it, so x equals 3. So that's 3. But we still have the 3 from before. That's the one that came out in front. So our final answer is perhaps best in a new color, 9. All right, so try the example below. So using the different laws that we have just used, the product law, quotient law, and power law, see if you can solve that question. Pause the video now, try it out, and see if you get the same answer as me. All right, so let's take a look here at this final question, this challenging one here. All right, so notice that we have a bunch of things going on, but we have some subtraction and we have some adding. So let's see if we can do something about that. First of all, we can put this 2 back in. If you didn't realize that before, hopefully now you can understand that if it works one way, it can work the other way. So that's 8 squared minus log 4 16. So plus, and now what I'm going to do here is I'm going to, maybe I'm going to make that smaller is what I'm going to do. Now I'm going to work on the base 5s, but if we're adding them together, we can actually just multiply the insides. And now that I'm looking at it, I don't think this is going to work out to a nice number. You can always go back and use a calculator afterwards, but that's what we have so far. So now what we're going to do is add the, divide the insides for the 8 squared and the 16. So log base 4, but we have 8 squared, which is 16, divided by 16. I'm going to go 8 squared, that maybe just to show it. And then we still have the log 5, and this equals 100. And so now what we're going to do is try to solve both of these. So this one goes to 1. I guess I should rewrite it out one more time. Log base 4 of 1 plus log base 5 of 100. And so now we can try to solve both of these. So 4 to the x equals 1. Well, that would mean x is 0. And then this one here we have 5 to the x equals 100. And unfortunately, we cannot solve this. But what we can do is we can say the first part is 0. So now we can just change this to log of 100 divided by log base 5. And now we can plug it in our calculator. So not ideal, but I guess this is a good reminder about last class's work. So let's take the log of 100 divided by log of 5, and that is 2.86. Rather have given an exact answer, but I think this is a good reminder about 7.2, which is that we can change the base using this method. All right, I hope that this video helps you understand the logarithm laws a little bit better, the product law, quotient law, and the power law. Good luck.